Hello everybody, welcome to the stream. Quick introduction because this is the first live Twitch stream that I'm doing. I'm Michael and I'm going to work on gokrazy. For those of you who haven't heard of this yet, gokrazy is a pure Go userland for Raspberry Pi 3 appliances, meaning that if you have a Go program, you can very easily bring it onto your Raspberry Pi. In fact, the only moving parts that we have are the Linux kernel, the Raspberry Pi firmware files, then obviously the Go compiler, and then everything that gokrazy brings with it, which is very minimal in its system, and then just your applications. So this makes it very simple to maintain a good appliance based on Go only. In terms of platform support, the gokrazy has a couple of platforms, let me show you actually, that it supports at different support levels. So what you can see here is that everything that is marked in bold is actually tested in the CI setup. So that is on real hardware and also in like a QEMU that we have running on continuous integration. So you can see here that we have a couple of bold entries, at least one in every of these rows. So we have the Raspberry Pi 3B, the 3B Plus, we have the APU, which is a PC Engine's embedded computer, and then the more generic x86-64 target, which is just QEMU. So obviously the Raspberry Pi 3 is a little bit old at this point. The Raspberry Pi 4 was released I filed this issue on June 24th last year, so that was current then. And it has taken a little bit of time to make it work well with gokrazy. This has largely been because of the upstream Linux kernel support. So there were a couple of issues that we went through. First of all, we had to wait for a new upstream Linux version to actually get the driver support in there. And then even once the drivers were all in there, we had to change a couple of things in terms of how we structure our boot process. So we had to switch to partition UUIDs, for example. We had to enable more options for the network driver because by default it would not work with the PHY mode unless you actually enable the Broadcom PHY. This has taken us a while to actually diagnose because there is no dependency from one module on the other on the kernel build file level. Then we had to add new firmware files, that's trivial, and then I think, I can't even remember what the resolution for this one was, but the USB ports, eventually we got them to work. I think it might have just been a newer version. And then I have recently actually set up a Raspberry Pi 4 in our continuous integration setup. So now the hardware is available, and the one thing that is still missing before we can declare the Raspberry Pi 4 supported is including automated EEPROM updates. Because for the first time, the Raspberry Pi 4 actually gained an EEPROM chip, and the Raspberry Pi 3 didn't have that at all. So there was nothing to update, so to say. So in gokrazy right now, we haven't even included the EEPROM files at all. So if you just buy a Raspberry Pi 4 and install gokrazy on it, it will just run with the EEPROM version that you got it with, which is probably fine, but maybe there's issues in the long term where they could be fixed in a newer EEPROM, maybe even security sensitive, though I'm not entirely sure about that. Okay, so what we want to do is we want to grab these EEPROM files and then make them available in gokrazy. And when I filed this, I had two pathways for this here. Either we could have a separate repository or we would just include it in the firmware repository. So what we're going to do here now is I'm going to walk you through how the firmware repository works in gokrazy, and then we're going to adjust it to also work for the EEPROM. We're probably going to do it in a separate repository, and we're probably also going to adopt GitHub Actions in the process, just because they're a little bit nicer to work with. They have quicker feedback time, and if we're setting up something new, it might as well be on GitHub Actions already, or not on Travis anymore, which we used before GitHub Actions was available. All right, if you have any questions at any point, please let me know in the chat, and I'll try my best to answer them. Or if you have anything that interests you about, either the setup or how I do things, or how, additional details about how gokrazy works, please feel free to ask. All right. So let's see where we start. So first, let me show you that here in terms of desktop setup, I have a Raspberry Pi 4 connected. I have it on a power socket that I can easily turn off and on, so I can easily reboot it. And this is the serial output. If I press enter, we have a serial console. This was the issue that I had fixed on the last stream. That was yesterday. So now we can actually use this to like poke around. And one thing that we can do is, let me make a temporary boot directory here, and then let's list the devices. I'm gonna mount defmsc blk1p1 onto temp boot. All right, and so these are the contents of the boot partition, just so that we know what we're dealing with. And it's up to us to change these now so that the firmware files are also in there. All right, questions. So is there anything special to ARM64 or AMD64? I have a spare router with OpenWRT which uses MIPS and just want to play with Router 7. So the differences between the platforms are usually in how they boot up. So the ARM64 support that we have is tied to the Raspberry Pi. So we ship the firmware files, which on the Raspberry Pi is also the bootloader. So for example, you can see the command-line.txt file that we have here. That file tells the Raspberry Pi GPU bootloader actually how to boot the kernel. So on AMD64, this is different because you have the BIOS or UEFI on newer systems. So you need an actual bootloader in your gokrazy image. Now we have added support for this on AMD64 for the Router 7 project. But I don't know, like your MIPS system, if it's running OpenWRT, chances are that it needs some weird bootloader setup. So if you are willing to figure this out on your own, like how to make it boot, then chances are that the rest will just work. Okay, next question was, how is the Pi connected to your computer? Via Ethernet or serial? It is a serial connection. Yeah, I have a USB to serial adapter right here. In fact, if I switch here, you can see that I just have screen started on def tty USB 1, and that is the serial console that I prefer to use. And then the next question was, what kind of processes are running on a gokrazy appliance? Yeah, we have like a little showcase here where we have a couple of select appliances. The first and foremost, Router 7, which was already mentioned in the chat. So Router 7 is based on gokrazy, and let me show you the picture. So this is what is on my desk, a little bit tidier than in this picture. And this is a PC Engine's embedded router, and I'm running only Go software on this to actually do like all of my internet connectivity. So let me see. Yeah, so you can go through the README. It's a little bit lengthy, but I thought I had like a list of daemons, probably not, just a list of state files and ports. But what you can see is that we have like a couple of different daemons: DHCP server, DHCP client, router advertisement, DNS forwarding, etc. Everything you need to have a computer come up as a router. So that's what I'm doing here in this one case. Then I have an SSH backup controller, which essentially just uses SSH to log into other machines and trigger a backup. I have a Homematic house automation central control unit implementation in Go, because the implementation that it came with was in Java on a way underpowered box. I heard that Homematic has actually improved this in more recent versions of their product. And now it is actually like a properly spec'd embedded box that doesn't crash all the time. But back when I bought their stuff, the device would restart every 2 weeks. Okay, so let me show you a screenshot of this, because this is quite nice. So yeah, you can see like sensor values for temperature, humidity, etc. Essentially, this gives me just a lot of flexibility. So I have a couple of things like this. Another one is my scanner stuff, where I can just put letters that I receive into a scanner, and they're automatically put onto Google Drive as a PDF that is then full text searchable. Somebody else actually wrote a little appliance called Beatbox, which is like a children's toy for his children, where you have like these NFC figurines and music that is playing. So that's also a fun project to check out. Essentially, you know, anything where you just want to write a little bit of Go and you don't want to deal with the Linux distribution, gokrazy is a good fit. All right, and then you were asking what processes make up the basic system besides the special use case. So if we just run PS here, you can see there's really not a lot going on. We have gokrazy DHCP, randomd, and NTP. You can see NTP has two processes because one of them is running as user nobody for privilege separation. In fact, I think this is easier demonstrated if I show the web interface, where it actually segments these into the different processes that it knows about that you built the image with. So the DHCP client is self-explanatory. It needs to obtain an IP address for IPv4. For IPv6, this happens on the kernel level. You don't need any extra processes. Then NTP to synchronize the time, because there is no real-time clock on the Raspberry Pi, so you need to synchronize the time every time you boot it up. Randomd is for managing the random seed, for storing it before shutting down and for restoring it on the next boot to augment the entropy. Then we have the Hello World program, which in this case is continuously running and just prints Hello World. And that's all it does. So this is like the demo for getting started with gokrazy. We have the serial busybox, which is the thing that we built in yesterday's stream, where it just bundles a version of busybox and then unpacks it to a special location so that for the serial that we just saw here, like the shell that we're using in here, it will pick this up and then take the busybox from there. And then last but not least is break glass, which is sort of an escape hatch for this entire system where, you know, all of these processes are written in Go. And very intentionally, there's like no open ports for like logging in and doing anything interactively. But if you do want that, and you do want users to be able to upload arbitrary binaries for debugging and then start them with an interactive shell via SSH, then break glass is the program that you would use for this. And then the rest here, we have the memory usage of the device, the storage usage, and the network addresses that it has. Hey, Matt. Nice to see you. Strange that it didn't notify you. Maybe I did something wrong starting the stream, though. Okay, so this should be like a good first overview into gokrazy, but let me know if you have any additional questions. So now that we have this, let's actually jump to the firmware repository. So what we have in here is all of these files that we previously actually listed on the boot partition. So this looks very similar. We have like all of these elf files and dat files in here, bootcode binary files. And then we have a couple of auxiliary files like license, readme, gomod, but also firmware.go. Will you consider using uroot instead of busybox? I read it in some blog post. Yeah, somebody else mentioned the same thing on Twitter today. I should probably totally use uroot, but I'm very accustomed to busybox, despite me struggling for a while yesterday to figure out how to cross-compile it. So yeah, I should probably give it a try. It would be a nice enhancement. Maybe we can work on this on stream some other time. Okay, so the firmware.go file here is just empty. This is just so that this repository is Go-gettable. The package management that gokrazy uses is just a Go tool. So anything that we have is a Go package. And then, let's see, in the command there is the gokrazy update firmware, which actually, so this is getting a little bit unwieldy for terminal exploration. So let's switch over here. Okay, so this program here, if we go to the func main, it does a few things, but it's not that long. So why don't we go through it? Okay, so we have a little bit of plumbing in terms of authentication for GitHub, because the program will actually deal with like GitHub pull requests and automatically merge things, etc. Like the whole automation around gokrazy is pretty elaborate, I would say, but it mirrors what humans would otherwise do. So you'll see this later on as we go through the pull requests. Then we have the firmware files, which is essentially anything in the repository that we just saw that matches these glob patterns here, so all the elf, bin, and dat files. We calculate the git blob hash of all of the files. We do all of this in parallel because why not? The hash calculation itself is single-threaded, so we might as well leverage multiple threads if we have them. Then we get the GitHub contents. So this is a GitHub specific API. It's not the Git API, it's GitHub specific, to actually check the upstream repository. So you can see here it goes to repos/Raspberry Pi/firmware. So what our repository does is it mirrors the Raspberry Pi firmware repository, but it also filters it. And it also adds the continuous automation. So when there is like new stuff available in the upstream Raspberry Pi firmware repository, you will not automatically get it in gokrazy, but you will automatically get it once it has been tested on real hardware. So that's sort of, a big piece of the puzzle in terms of what makes it easy to work with gokrazy, because you don't have to do any of these updates yourself. Okay, so then we start, what do we do here? We check the firmware hashes with the contents, and if they mismatch, then we're updating by doing a HTTP request, adding authentication headers, and then getting the Git URL here, writing it to a file, and that's all we do. So this is relatively simple. That's like the whole program. There's a couple of helper functions up here, but we've just reviewed this whole program. And then the rest of the logic is here in the Travis configuration. So as I mentioned earlier, we are still on Travis instead of GitHub Actions, but we're trying to change this. Starting one repository here on stream today. Let's see how this goes. So we have a couple of instructions here. The go firm check, not gonna trigger very often here, seeing as this repository is largely just a dump for firmware files with a little bit of logic to actually automate it. Then what's this? Oh, this is just a quick check if everything compiles, and then this is which of these files are not gofirmed. I should probably simplify this also. I've done it in a different repository in a simple way. And then here with the Travis secure envars check, we just check if we're running in the context of a pull request or in the context of like a continuous run, where we have the secure environment variables available or not. And then we get the tooling. We have a separate repository with the auto update command, and then we also get the gokrazy packer. Because what we're going to do here is we're going to start the gokrazy boot program, which talks to what's called the bootery, which I can show this to you in a second. And then if that works, we're going to merge and terminate this run. So this logic is relatively complicated to understand. I'll elaborate on this in a second. And then the rest of the file has the instruction for the gokrazy update firmware program that we have just seen. It will run it, and then it will amend the pull request that it is running in. And that amending the pull request will trigger another Travis run. So what you'll need to understand is that these are all chained. So the first Travis run actually starts here, so to say, in that this is going to be triggered by a cron run that I've configured on Travis. So like every day or so, I think it's every day. So at some hour during the day that Travis thinks is convenient, it's going to run this. So it's going to run the update firmware. It's going to find new files if there are any new files. It's going to update the pull request. Changing the pull request triggers a new Travis run. And then it starts again into the file, but now it goes into this code path where it will do the tool getting, and then it will do the boot testing on real hardware. And if that actually works, it will merge immediately. Yeah, so it's just 2 iterations here. I think it's more iterations in some other of my repositories for this project. So this is what we have in front of us in terms of work. Any questions up until here, or are we just gonna start getting right into it? Okay, let me know if you have any questions. So otherwise, what I'm going to do is I'm going to go back to the GitHub issue. I'm going to create this repository here. So this is rpi-eprom. Have you looked at GitHub Actions yet? Yeah, I mentioned that we're going to set these up, migrating things over, also use build source set, which is not bad. Yeah. Yes, this is on the menu. Yeah, I've been pretty happy with GitHub Actions so far. I hadn't, for the longest time, I didn't actually look at it because it was still in beta, and I didn't know for which of my repositories to like ask for beta access first. So I didn't want to make a decision, and I figured it was all new and growing pains, etc. But now at this point, where they're like generally available, and people have sort of figured out the kinks, I think it's good to adopt. And what I'm seeing so far, I like it. Okay, so let me see. Okay, cool. So this is the Raspberry Pi repository. This is going to be our upstream. I'm just going to actually make sure that this is spelled correctly. Then we're going to do a git init. We're going to do a go mod init. I'm going to copy and paste this here. Okay. What else do we need? So let's actually go back here. Raspberry Pi Eeprom. Gonna open this up here. Gonna open up the other one here. Okay, cool. So in the other one, we've had this firmware.go, this empty file that was just there to declare any Go package, really. So we're gonna add a Eeprom.go here and say package. Ooh, I'm not sure. I don't think this is gonna work. I don't think I can make it package rpi-eprom. So I think I'm just gonna go with Eeprom. And then this comment is still the same. So I'm gonna do it like this. Okay, actually, let me go back to this layout. Oh, nope, that's not what I wanted. Okay, I'm gonna neutralize this here so I don't make the same mistake again. And then here we have our empty Git repository in which we just have these two files. So why don't we stage them? Say initial commit them. And now we should actually do the same thing here. github.com, gokrazy, add a new repository here. Okay, for consistency, let's see what we put in here. What is the Emacs window in the bottom right doing? Excellent question. Okay, let me tell you about Maggot. So Maggot, as you can see here, is a mode or a package for Emacs, which I think, oh, maggot.vc for .version control. Oh, in the left. Okay, I'm going to talk about both. The one in the left was still set up from yesterday's stream where I did an update of the attached Raspberry Pi. So that's not necessarily wrong, but I didn't want to update it right now, so I killed that. The bottom right is how I was interfacing with my Git repositories just now. This is an Emacs plugin called Maggot, which is absolutely fantastic. You're going to see me use this all the time in the stream. I think all of the things that you can do in Git are like super well represented in Maggot, especially like things such as, oh, I only want to stage like this particular line, or I want to rebase interactively the last 7 commits and rearrange them this way and reword this one and fix up that one. And it's just a pleasure to do this in Maggot, and it's always horrible to do it on the command line for me. So I'm a big fan of this, and hopefully you're going to see why. Hope that clarified the question. Okay, so this was called bootloader files for the Raspberry Pi 3. I'm going to say EEPROM files for the Raspberry Pi 4. Make it a public repository. No init. All right. So for simplicity, just gonna steal that here. Copy and paste this. Okay, so Maggot picked this up. It now knows about origin/master. And in here, we should see our files. Nice. Okay, also gonna like disable wikis and projects because we don't use these here. Okay, let me actually check. Yeah. And then I think we had a license.broadcom because that's what the firmware files are licensed under. So let's just figure out what the EEPROM is actually licensed under. Okay, so wait. It has firmware slash and the rest. And firmware slash stable. Yeah, that is where we want to take our EEPROM from. So in terms of license, firmware slash is license custom, and this custom, it looks pretty similar to the BSD3 license above, but it's not tagged BSD3, so there must be differences. So I'm just gonna copy this here. And then let's see, this is the EEPROM file, license dot, I'm gonna say EEPROM, just gonna paste this in here. This is formatted like a Debian / license file, so there's like dots on lines that don't have other content, and it's wrapped a little bit weird, but we're gonna leave it like this. And then the other file, we can actually just take this one here, because that's for the code and not for the firmware files. Okay, let's see. This is that license file. Let's say EEPROM.go, EEPROM. Okay. Stage both of these. We can actually amend the initial one and then force push, because nobody has used this repository yet. Okay. So now we have a license too, which is good. Okay, so now we have like a repository, but it is empty. We're going to change this by actually porting over the update program that we had for the firmware, and we're going to make it work for the EEPROM. So that would be command gokrazy update firmware, and then we're going to be in here. Gonna navigate here to, EEPROM, okay. Gonna add command, gonna add gokrazy update EEPROM, and then gonna copy this file. Oh, actually, let me erase this into here. All right. Oh, actually, rename it to eeprom.go. Cool. Now we have the untracked file here, and we can actually start editing this. So most of this stuff is going to be the same. Let me rename this to EEPROMref. So this updated all of the occurrences. There's just the one, but it's nice to get into the habit of using the LSP-based rename so that everything is updated. I understand other editors get this for free, like I think in VS Code it's implemented or integrated a little bit better. In Emacs it's good enough, but you need to think about what you're doing, like there is a special command for it. Okay, this is a git commit hash of the rpy EEPROM to take EEPROM updates from. Okay, this one obviously won't exist in that repository, so this is the one. Just gonna check the latest commit. It's gonna be this one here. Add it here. Okay. Let's see. The GitHub content stuff is gonna be very similar. Here we need the Raspberry Pi EEPROM. Now the files that we are interested in are in firmware, stable, and then they're all .bin files. Let me double check the description here. This also only talks about bin files, though we need to rename one of them later. Actually, two of them, I think. The ones that have the date and version number in them, so that we trigger the update process. But anyway, so this is all .bin, so we can just remove the other glob patterns here. And then we're gonna do a rename here. Firmware file is gonna be EEPROM files. Whoops, that did not work out correctly. Did I neglect to save this buffer? Wow. Okay, so now I'm a bit confused as to what's happening here. One thing I can do is I can just shut down the language server just to make sure Oh yeah, that works better. I think it sometimes has that, like it's sometimes a little bit unstable, but it's always hard to like reenact this after the fact. Though I suppose now we have it on stream, so maybe that helps. Okay, so it's going to go through the EEPROM files. It's only going to look at the ones that are actually present in the local checkout. So we'll need to seed this, so to say. Like we need to place the files in there in one version, and then it's going to be able to pull in the newer versions. And we're probably just going to seed them at an older revision so that we can see that the magic is actually working. Okay, cool. So now this should be EEPROM, the upstream repository. The rest should be okay, I think. We're going to find out if not. I think this might be Raspberry Pi firmware. I think this might be a subdirect. Yeah, it's boot / and that has the files in there. Here, what we want here is firmware / stable. Okay. And then I think it should just download them using their base name. So they should all end up in the root of our repository. So there's no nesting going on here. Okay, so let's see. If you just do a go run, okay, so it ran. It didn't say anything, so that must mean that it is happy with the state of the world. Make this larger. Let's try if this works. Okay, and I think this is because if we print the EEPROM files here, yeah, so it just doesn't find any EEPROM files, right? Because the directory is still empty that we have here. Like there's no files matching .dat. So we're gonna pull some out here and we're gonna check the history so we can actually get like an older version. So this, I think, let's have a look at how these are structured. So the Pi EEPROM file is updated, the other one not necessarily. So if we were to use this version here, let's say browse files, firmware, stable. Oh, it has multiple versions in there even. Huh, so how does it do that? I was not expecting that, but yeah, maybe we just like need to sort them or have some other sort of policy as to which file we prefer. Okay, anyway, oh, this actually might be tricky because this changes our logic in that this file has like a variable name. So we're not going to look for it if we're going to use the same code that we have been using so far. So let's have a look. We could just, yeah, this is going to be terrible, I think, because it's going to be like a very lengthy JSON output. Oh, not so lengthy after all. Nice. Oh, right, because this is our contents function, and that's already very streamlined. Okay, so in this case, I think I'm just going to flip the logic around, and I'm not gonna, I think I'm still gonna collect the EEPROM files, also because I have their hashes then, which I need for later comparison. I'm just gonna change this one loop here where we previously took the EEPROM files as like the canonical source of truth, and we're gonna change it to just iterate through the contents here. Okay, let's have a quick look at the contents. It is of type content entry. So let's arrange it like this. Okay. So what we want in here is path, let's say CE for content entry. Or actually, let's make it GitHub content so it is consistent. Okay, and then I think we're just going to change the logic so that it always just downloads all of them if they're not up to date, even if they're not found. So it will be firmware hashes for path, I think. We're going to find out. I think this might just be the base name. Let's see, index, EEPROM files. Oh no, this is literally the index. Oh, that's not good. Oh, this is also a slice actually. So we're gonna turn this into a map. So this is gonna be map string to string. And what we're gonna store in here is gonna be a path.base of path. Okay, the index we no longer need. Actually, let's remove this entirely. Also here. And then what we should be able to do, oh yeah, just a file name like this. So if not okay, we should download it. So that means if it's okay and the local hash is equal to the GitHub content.sha, then we're going to skip it because it's going to be up to date. And otherwise, it's either not found or not up to date. So in that case, we'll need to download it. Okay, and we should also log the local hash. So be local hash and the GitHub hash, which would be this one. Okay, let's give it a shot, see what happens. Oh yeah, I know. It did do something, but I did run it in the wrong directory. So go run, not so good for this. So we're gonna need to change this. Change our compile command to go install and then cd into, let's see if this works. Yes, into here, and gonna run this command. Okay. Nice. Okay, so now we have the files in here. I think one problem is going to be that if the files are renamed, like if a more recent version of this one comes in, the old version will still be here because we don't clean them up. So we're going to add a to-do for this and then maybe defer this until later. Let's just see where this would logically fit into here. This would be where... Oh yeah, so I think we would need to, when we update a file, and that is, if it's either found actually or not found, doesn't matter, no, not up to date, then we're going to delete it, and then what we can just do is we can just print the leftover files here. Okay, just going to do it like this. This is a good enough first iteration of this. Okay, so now if we're going to run it again, this is interesting. So the recovery.bin, it shows a different hash locally than on GitHub, which is interesting. Let's see why that is. So what are we doing here? Okay, let's print here. Okay, I can say full path actually, that works. And now we should have all of the details that we need. Okay, so recovery.bin says this is the local hash. And on GitHub it says it finds it under this hash. Which, yeah, that seems to be true. So why won't it download it correctly then? Let's see, CC640. So I think this is the download URL. Just plug this. So this is file recovery.bin. And we just download it manually like this. I wonder what it says now. Oh, it still reports something different. But this time the hash is different. So that is suspicious. But no, it is the correct file contents. Or it is some file contents at least. But also, like, the size of this is different. Oh yeah, that's different again. Did you see that? Like now it's 119K. That is so weird. I wonder if this URL is somehow malformed, like in a subtle way, in that, you know, maybe we are, yeah, I don't know. It looks kind of cracked. Let's check in the browser, see what URL we get here. So the recovery.bin, if we say download, I guess, getting a raw URL, oh, that links to a different version anyway. Are we gonna get like a blob URL for this? Oh yeah, this is a blob URL. So we have a similar one up here. Actually, yeah. Let me remove the camera pic for a second so you can compare these. So this says, oh yeah, this is api.github.com. So it has the additional repos in here, it has the additional git, it has blobs, and then it doesn't have a file name. And I wonder if that might be part of the issue. So we're gonna see. If we're going to use okay, so 67K is recovery.bin. I think the hash that we're doing is like a SHA-1. Yeah, just SHA-1 of the thing. But then, oh no, actually we're hashing the special git blob thing here. Okay, so I think we actually should run it. But yeah, it still complains. But this might be because now we are using a different git commit here. So I think we should browse the repository at that revision. Yeah. And then if we're using the view raw link, sorry. Recovery.bin. 86K, compiled again. Okay, so now this tracks. Interesting. So the URL that we get from GitHub works, which, you know, that's a good start in the web interface at least. So now let's figure out what is different about the URL that we have here, and where does it actually come from? I thought this comes directly from the GitHub API. So to use plain Emacs key bindings when editing text, or to use eval mode, or a combination. I use the plain Emacs keybinds. When I was learning Emacs, I wanted to have like the Emacs experience and not like a strange plugin. So I decided to like learn the Emacs key bindings. And it has paid off, I think. I wouldn't want to use eval mode, not because I have anything against it, just because it's not the experience I'm looking for. Are you still viewing your virtual X desktop via the OBS preview event? I am actually, yeah. It works. Okay. So let's go back to this. This was AD18, etc. And in here, we have the CC64. So, okay, so the URL that we're given here is, it has like, why does it have, okay, let's step through this. The GitHub contents here just has like a GET request on this URL. So I wonder what happens if we do this GET request. And then as the ref, I think we're going to plug in this, which I think this is what we use here, right? Yeah. Okay. So this is what we get from GitHub. If we search for the recovery.bin, it's here, and then we have the git URL. It's just this. We also have the HTML URL, which actually, like, this looks more reasonable, I want to say, because this is the same URL that the web interface gives us. So maybe we're just going to switch to this one. And then there's like a download URL. Oh, maybe we should be using that one actually, and not the Git URL. That's worth a try. Yeah, still 86K. Okay, why don't we give that a try then? So instead of Git URL, I'm going to use download URL. Maybe this is just like pure coincidence that this worked before. Download URL for the other repositories. Okay, so now I'm gonna remove all the files again, run it again, got all the files, run it again. It's weird that it kind of converges in that, like, it shouldn't have to download these files again now, right? Yeah, it's... What is happening here? Do we actually print the URL that we use when we download these? I think no. Oh, it's just download URL. Okay. Oh yeah, and we don't properly print this, so why don't we actually print it here? Oh yeah, I think I know what this problem here is. Whoops. Yeah, static check would have told me this, I think. So yeah, maybe at some point I should actually start using it. Okay, yeah, that looks much better. Now it no longer fetches them over and over again. Yeah, where's Dominic? I don't know, man. He should force me to do this. Force me to adopt static check on stream. Otherwise, I'll never do it. Okay. So what do we have now? EEPROM files. That's okay. This is all like debugging stuff. So we're just gonna remove, or actually, we're gonna leave this in and then remove it later. Okay. Switch back here. So we can actually commit this already, and then the next step is to actually get this running. What was the issue? Oh, I'm sorry. Okay, so what we did here, let me make this a little bit larger so it's easier to understand. Okay, so I've highlighted the lines here that are relevant. Excuse me. Specifically, we are starting a new Go routine here, the deg.go, and then in that Go routine, we're accessing GitHub content. Before, like, the bug was that we didn't explicitly copy GitHub content before, so we were using the GitHub content out of the for loop that we have here, like the for range loop, and that changes on every iteration. So the Go routine that we spin off here was actually erasing GitHub content for either the contents that it had in the iteration that we spun it off in, or the next iteration. So yeah, pretty classical bug in terms of spinning of Go routines and not actually properly capturing these variables. But yeah, it happens. Okay, that is a common issue. Yeah, right. That is why there is a static check for it. But yeah, maybe the Go language server should do like the squiggly lines, like it does here for whatever reason. It says it's not in my go.mod file. Is that actually true? Go.mod. Xsync is in there. Yeah, this is not correct. Eaglot shut down. Eaglot. Yeah, now it's happier. So it didn't like pick up on the changes to the go.mod. Strange. You can turn on static check support with it. With the language server? Yeah, maybe I should do that. I think that would actually be my preferred way of using this. Okay, so we wanted to use like an older revision. Let's double check that we did that by firmware stable history. So we are at, wait, why does it look different? Oh, because we're browsing it at a revision. Yeah, that's why. Okay. So now 19C6 is the latest, and I think... Oh no, we actually just plugged in the latest commit. So we should do an older version. Promote this to a stable update. Yeah, why don't we use this one? Because then we can actually verify that when we want to run it on the continuous integration, it can actually find a new version and update to it. Okay, so remove all the bin files again, run it again. It will fetch the old version. It will try fetching the old version. This is good. This is what we expected. Good. Oh, then we could actually also test pulling in the new files, but one thing at a time. So let's do the go.mod, go.sum, all of command slash. Oh yeah, and we already, I think we already have this problem here. So let's just run this again. Oh no, it's just the two versions are all in there. Okay, cool. So add gokrazy update EEPROM pull old EEPROM version. Good. Push this upstream. Okay. So this is the repository we're interested in. These files are here. Good. So now that we have this update program, one thing that we can already do on CI is we could run this program and just verify that it works. But ultimately, what we want to do to actually update to a newer version of the firmware is essentially we're going to edit this file and just change the EEPROM revision here to a newer Git hash, right? A new Git reference. And for that, we actually have automated tooling, or we're about to make it. In the firmware repository here, we have the Travis YAML. Oh, actually, sorry, let me go into the cron here. Yeah, empty cron.go, and here the Travis YAML, let's see. Exactly. So this is what we're looking for. This is the pull firmware command. So we're going to do a pull EEPROM command. Okay, so this is command gokrazy pull firmware. And actually, I'll close this. So what this does is it looks at the contents to see if anything changed. And then it gives back the SHA. Well, what's all of this? There is, oh yeah, this is where it gets the latest commit and then modifies the file and then does like this replacement of the firmware ref constant, or in our case, the EEPROM ref constant. It will create a commit, create a ref, and then it will auto update. That's response here. Okay, cool. Yeah, so this is essentially tooling that will automate the human part of checking for a new commit and then updating the reference to it. So we run this from Travis cron. So I think it is time for us to first of all, have the like this, have the version of it for the EEPROM code. Then verify that it works, and then we can start configuring the GitHub Actions. Any questions up until here? I think now is a good natural stopping point for now. Okay, so let me check this out. Emacs always looks like magic to me. Yeah, maybe that's just because I'm using it really fast, because I'm used to everything. I can like, not only to you, huh? One sec. MX magic, that is it. So, MetaX butterfly. No go files and auto update. Yeah, that is okay. Yeah, I don't know if I can be like, I think there are programs that will show which keys I'm pressing. Oh, is Dominic joining us? Or maybe I can just like, you know, I don't know which parts are particularly magic-y that I could then explain. Yeah, just let me know. Way to call it the lurker. Okay, let's go into update, auto update, switch to go modules, okay, command, and then in here, just gonna copy, gokrazy, pull EEPROM. Recursive copies, yes please. Cool. And then rename this, pull EEPROM.go. Okay. Yeah, there is software that shows key presses, but it's a bit awkward because you need to remember it's there if you type passwords. Oh yeah, very much. I'm trying not to type passwords here on stream. I'm just like pasting them from like outside the sessions. But yeah, it's a good hint to yeah. Should probably have like an opt-in mode for this. Cool. So what we're gonna do is update a bunch of references here too. This should be RPi, Eeprom. This should not be boot, but firmware stable, I think, or maybe this is actually a parameter. I think this might be a parameter. Yeah, it says owner repo. Okay. +1 to a password entry secret scene with just webcam. That's what I do. Actually, so I have this screen here, which is just like black, right? So I could bring this up during password entry, but yeah, not entering passwords at all, even better. Okay, so let's see, we have elf.bin.dat. I think the files that we were interested in actually, let me go source, give it a crazy, all of them are bin, so this is good enough. Okay. Expect number of commits. Just correct commit dates. Yeah, sure. We're just gonna assume this. Update EEPROM.go. That is the file. What setup are you guys using for streaming? Oh my god, yeah, it is a very complicated setup that I have. But I think the part that you might be most interested in is I'm using OBS. Used to stand for Open Broadcasting Studio, I think. It is an open source program that makes it very easy to just capture your webcam, put it into like the little corner that I have it here, and share your screen. It does like shared memory capture of the X11 desktop. So this is very efficient, and then it also like outsources all of the encoding to your graphics card, which also makes it very, very efficient. So I can like stream here. Let's see. So I have a like CPU load right now of 2.2%. It does a 60 FPS stream, and it also records this. So yeah, can't complain. It indeed makes it very, very easy. Okay, let's see here. Update EEPROM, EEPROM.go. Firmware ref. That is EEPROM ref. Do an eagle-out rename here. EEPROM ref, regular expression. All right. And then we're replacing this with the code. You get NVENC going. Yes, I do. The AMD equivalent doesn't work on Linux, but the Ryzen doesn't even sweat with streams to Twitch and FFmpeg local file. Yeah, I'm glad to hear. I wouldn't have assumed that, you know, it's a big problem. I think the main reason why this is so well supported is because a lot of people use OBS for streaming their games. And in games, you typically have your computer going at maximum rate anyway, so you might not want to add too much software overhead. But yeah, for like it's I'll take this, right? It's good situation that we're in, that the NVENC works so trouble-free. I literally have not done anything. Like this is in general my experience with the NVIDIA driver. I used to remember that like many years ago it was a giant pain in the butt, and it always broke on updates, and there was always like kernel version incompatibilities, etc. But it has not been like that at all for many years for me now. I think for at least 3 or 4 years, I'm using NVIDIA graphics cards in all of the desktops that I have, like both at work and at home. And it's just problem-free, both on Debian and on Arch Linux. Like I just have the proprietary drivers, everything just works. It pains me a little bit that it's not open source, but in terms of practical usability, it's actually really good. Okay, so let's see here. I think the rest should be okay. We might actually want to like rename update firmware to update EEPROM. I had one time where I updated NVIDIA blob on a work desktop and totally destroyed all my Xconfigs and left my machine unusable. No idea how. It's easy to just reinstall. Oh yeah. I feel for you. This reminds me of the NVIDIA bug that was kind of famous where I think their updater had like a space in the wrong place, and that way it was rm-rf/ under certain circumstances. Yeah, I think very famous bug. Yeah. Blue Jean's mentioning it. Maybe somebody can like post the link in the chat for people who don't know of this bug yet. Certainly, you know, amusing as an hindsight onlooker, not so amusing for the poor people who had to undergo this and then actually took the time to figure this out and report it. But I guess at that point, yeah, you would want to. Steam too, yes. Steam also had a similar bug like this. Doesn't RM require a special flag to remove the root? Yeah, it now does, yes. Yeah, this, I don't know if it always, like, I don't know for sure if the no preserve root option was introduced as a response to that, or if it just affected systems that weren't new enough to have that flag, or if that was because as the super user, you might not have to specify that flag, or maybe it actually did, like, I don't know. It had circumstances. Oh, 2015, that was when it was. The Steam one, okay. Yeah, I don't remember which year the NVIDIA one was, but yeah. I mean, obviously it had an effect, right? Otherwise people wouldn't have been so upset and so many computers wouldn't have been deleted. So there must have been a way that this works. Okay, cool. So we're gonna install this program here now just to verify that it builds, and it does, so that's nice. I don't know yet whether it works, so let's see, we're in here now. Oh, so I have aliases that are single letter for essentially everything. Like, I used to use Vim with V, and then I had capital V, which is pseudo Vim, which I like. Nowadays I use E, which is a little bit more complicated. Oh, did this work? I don't know how this worked. I think, no, I don't know. How does gokrazy work on Raspberry Pi 4? I'm tempted to play with it. I'm going to say very well, except for EEPROM updates, which is exactly why we're here. No, more seriously though, I have been running all of my workloads on the Raspberry Pi 4 for the last couple of weeks. During development, I have not noticed any instability like that. The current kernel version that we use on it, which is 5.6.14, the 5.6 release in general is really good, I think, for Raspberry Pi 4 support. Which E should work? Oh yeah, nice. I always forget, there's like so many ways to show this, and only one works in the different circumstances. Yeah, so this is just a wrapper around my Emacs client, which, you know, believe it or not, is called Zemax client, so that Zshell doesn't automatically parse this name, because it otherwise does. Let me see if I have this. I think I have this in here. Oh yeah. So that Zshell wouldn't recognize it as Emacs, and I think this was like Zshell trying to be helpful, and I think, yeah, it would like change the key binding mode. So, you know, depending on whether you had like Vim key bindings or Emacs key bindings enabled in your shell, this would change depending on the editor variable. And because I was using Vim key bindings at the time, because that's what I was used to, but I wanted to start Emacs, without my shell knowing that I did it, I had to like rename it like this, from Emacs client to Zemax client. Okay, and then I have capital E, which is like, you know, the relation between lowercase v and uppercase v is the same as lowercase e and uppercase e, except uppercase e actually doesn't start Emacs as sudo. It starts Emacs as my user and then uses this special path to do like a remote path to the local machine and use sudo, which is very fancy. But this allows me to, like, you know, if I did e @c group, I get an Emacs with my config and system permissions. So I could totally just, you know, modify system files like that. So that's what I do. Okay, so we got thoroughly sidetracked, but this is git status. The repository is clean. So we have just installed the gokrazy pull EEPROM command. I'm gonna run this here. Oh yeah. Travis repo slug is going to be gokrazy rpi Eeprom. GitHub user is going to be, can I not specify this? I think I must right now. Yeah, it doesn't want that. So let me just, I think, oh, yeah. Let's see what happens when I just comment it out. Will it magically start working anonymously? Nice, yeah. Just realized your stream is 1080p 60 and got jealous. Yours is 1080p 30. Ooh, yeah, I don't know where the difference comes from. Like, why is mine 60? I don't know. It was like that when I set it up. NVEnc, I'm sure. Yeah, that could be. That could be. Okay. Okay, so what's it saying? What did it do? It didn't do anything. It checked the last commit. Base tree. Oh, and then the because it was trying to 8K 60 content when. I think for 8K 60 you legit need NVEnc, and NVEnc doesn't support 8K resolution. And Twitch caps it at 6 megabits. That is true. Not necessarily sure whether we would need the full 6K. 6M, I mean, because like nothing moves so quickly here, right? But yeah, I don't know. But I think Twitch also has a resolution cap, so I suppose I could try to do 8K 60 and then just stream it on my own RTMP relay. Not that there would be anyone who could actually then consume that stream, but I suppose it could work. Bandwidth-wise, you're good with Init7. Cheers from another Init7 customer. Yeah, cheers. I am very good. My upstream meter says it's like 15 megabits. Yeah, this is like, who cares? 15 megabits. Okay. Could totally do like 10x that. Okay, so this now complains about the post request failing. I think this is because it was actually trying to update the EEPROM, but it was trying to do it all on the GitHub API, which I think this is also why it complained when we didn't specify the GitHub environment variables. Did you by chance install the OBS Studio Prometheus exporter plugin? Not yet. I can share the dashboard JSON too. Yeah, that would be nice. Let's do this at some later point. Okay, so I think what we're going to do at this point is we're actually going to commit this. Add gokrazy pull EEPROM. Yep, going to push it upstream. Oh, I actually need to set this up. I think change this here, change it in the git config, change the origin URL. Okay. Try again. And there we go. I know there's better ways to do this, but I haven't set it up on this particular account yet. So we have added this new code. So we should, as a side note, we should probably totally refactor this later to like not duplicate so much code. But for now, we just want to get it working and then refactor afterwards. That is generally a good strategy. So let's close this tab. This tab we're going to need. So yeah, I think this is the point where we're going to start using GitHub Actions, because now the next step is like we need a cron thing, like a time-based trigger to run the program that we've just added, like the pull EEPROM program, which checks whether there is a newer revision available and then just sends a pull request that starts like the whole automation. So we're going to port this over. So this should be here. This should be in the EEPROM repository. Get started with GitHub Actions. Set up this workflow. I'm not going to do it in here, but I am actually wondering about your thoughts on pushing to master versus going through PR for your own repos. I sometimes do one, I sometimes do the other. So when I am mostly working alone and I need something pushed quick and I have little doubt about whether it is correct, or when whether it is correct or not doesn't actually play a big role, I just push directly because I like the quick feedback and I like low hurdles. But if I'm working on a bigger thing where either I want to have feedback from other people because it's not done yet, or I'm wondering what other people think, or it might need like a longer discussion period for whatever reason, then I do a PR for my own repos too. I have some repositories on which there is like a PR is a requirement and I can't push directly intentionally. The i3 repository is one of them. So I myself don't have direct push access. Nobody has to i3. Everything is code reviewed. That is how it should be. But you can only pull this off once your project reaches a certain size. So if I were to like send pull requests for gokrazy, nobody would ever look at them because there's nobody else monitoring that. So for the time being, I need to do it like this. And even at a later point, there are benefits for either way. And I think it is a trade-off and a subtle line when you need to change from one to the other. Okay, I had recently actually set up GitHub Actions for another repository. Makes sense, yeah, I think so too. For the Go i3 repository here. Oh yeah, this is where I found that amusing bug here where, so I'm running the tests in Docker here. I'm a fan of doing this because then you have like a lot more influence on the environment in which your CI is running. Whereas previously, like, you know, in here, what you get to say is you can say runs on Ubuntu latest. And then, you know, who knows what that might be or what that might be in like a year from now or 2 years. It can go either direction. Maybe they move too fast and your stuff breaks, or they move too slow and you can't use new features. There's always something that was wrong in Travis, at least, in terms of the update speed. So I've gotten into the habit of just using Docker, both to make sure that we have tight control over what we actually install and also to make this all a little bit more reproducible, which is also always nice. So it's much nicer if you can iterate on a local Docker run command line rather than having to like push to GitHub all the time and just wait for the CI. And in this particular case, what I was doing is I was running the i3 package test suite. So Go i3 is like, let me actually pull this up. Actually, let's use the new package repository thing. Just put i3. Yeah, there we go. This is like a little package which provides a convenient interface to the i3 window manager. Yeah, so you have a bunch of convenience functions. For example, there should be somewhere, let's see. Yeah, there is a run command. So if all you want to do is like automate something, your program could be as simple as saying i3.run command and then you specify your command. It does everything else under the covers. So this is very useful. Imported by for scripts such as, let's see, just open this one up. Go to the repository here. So this is an example program that you could build using this package. What I'm doing here, so let me scroll so that you can see most of this. This configuration, and then this is like the part that interacts with i3. So I'm getting the tree, I'm finding the workspace node, and then on the workspace, I'm checking if there is any child that matches the regular expression that I put in. And by default, this is like the Chrome regular expression. Jealous about this. Yeah, you should be. Use i3, it's good. And then if it finds Chrome, it focuses Chrome, and if not, then it starts a new Chrome instance. So this is why it's called Next Chrome for i3. So this, it brings up the next Chrome browser that you have, or it brings you a new one if you want one. So if you are working in a model like I'm working, usually not on stream, where I have like a Chrome browser up in every workspace that I use essentially, and one workspace per project. So then, you know, I can just use this key binding. It's very convenient. Okay, so that is that module. Oh yeah, and what I was doing here is I was running its test suite. And in the test suite, it actually brings up like a virtual X server. There is the XVFB, which stands for Virtual Frame Buffer. So this is like an X server that does not render to anywhere except like, you know, the virtual frame buffer. So you won't see its output. It won't disturb like your command line. Like if you run this test, it will not actually start anything graphical, or it would switch your virtual terminals or anything like that. It will do nothing like that. It will only like, you know, allow you to run your tests that use an X server in this. It's kind of like a namespace, you know, a lot less than that, but it gets the job done. Okay, and what the problem here was that it has this sort of readiness notification thing where if you want to start it and be notified as soon as it is ready, The way it works in the X server is you start the X server process and you set the signal handler for SIG user1, which is the first user-defined signal, to be ignored. And then the X server takes that as a signal to send SIG user1 to its parent once it's ready. So this is like super bespoke. Like, it is not like anything else. It's not like socket activation that systemd uses or any other established pattern. So this is really weird, as it's also a little bit tricky to do this from Go, in fact. I can show you the other change that I have here. I think it is in here. Yeah. The way we set this up is we actually install a signal handler for SIG user1 before we start the process, because there's no way in Go to start a process and then ignore the signal handler. So the way I had it previously is I had it set up so that it would actually ignore SIG user1, as you need to do for this protocol to work, and then afterwards set up a signal handler. But that is prone to race conditions, because then it might be that the command starts and it sends to SIG user1 before you get scheduled again and install your signal handler. So either we do it in a racy way, or we do it in the correct way, where we actually need to use a subprocess here and then tell the shell to ignore the user1 signal and then execute into XVFB. So this is not that great. But the next problem that I faced was that in this readiness notification protocol, the X server actually has an explicit check that verifies that the parent process is not PID1. And if it is PID1, it will just skip the readiness notification, so your test will just always hang. And the problem is that inside Docker, you're in a new namespace, so that includes a new process ID namespace, so you will be PID1, and then you would run into this bug. So the fix for it is to use the docker run --init flag, so the Docker will run a process as PID1 within the container, and then you're no longer PID1, and then the notification works. So that's why we have a load-bearing --init flag, which, you know, reads funny, but at least it has a funny story behind it. And now we're just gonna, now we're just gonna copy all of that over and start our new GitHub Actions. Jones was saying package go dev sometimes doesn't find packages I'll look for. Work in progress, I guess, and mixed feelings. What I've noticed is that package.godev doesn't show packages sometimes if they don't have proper modules declared. So I think or at least some parts of the pipeline, I believe, don't work. If some of your stuff is using modules and some isn't, because the package go dev side for i3, the module, like the package and the module works, but then it wouldn't find my next Chrome for i3 repository for the longest time until I started declaring the module in there too. And then I also needed to download it via the proxy so that it would be notified that this repository exists, and then it eventually showed up on package go dev. XVFB is great for fuzzing applications with UI. That's true. Also used it to run Spotify headless. Yeah, nice. And then you ran into the same issue this week. Nice. Okay, so let's go back to the task at hand. We wanted to go into the firmware repository, and in here, we're going to do a .github. Actually, let's do .github first. Just notice the creative in the tags. I like it. Twitch actually suggested this, so not up to me, but I didn't object. Workflows. Let's say cron.yaml, I suppose. Okay, copy this, paste it over here. Looks reasonably good. Okay, we have get dependencies. Had a couple of people find my stream due to tags and categories, so they're worth setting. I agree. I did actually add the programming thing. I don't know if there's any other categories that I should be setting. If there's like a Go specific one or something like that, tell me if I should be setting more. Okay, we will not use vet or build or test, I don't think. Actually, let us actually go here. This is what we want to port. No Go categories that I know of. I do wonder what would need to happen for a Go category to be added. Hashtag Emacs. Yeah, I don't know if there's no Go category. There might not be an Emacs category either. But it did actually announce on Twitter in the Emacs hashtag. So maybe there's Emacs. Say hi in the chat if you found this stream via Emacs somehow. Okay, so this is what's happening here. Okay, so this is what we want to port. Right, so the get dependency step here, we can just we can leave it, but we don't really need it. And then instead of getting the dependencies, we're going to get our program here. that we just added for the automation, and then I think, wait, so if the secure environment variables are not true, oh yeah, then it succeeds, or it runs this if it has the variables. We do have the variables on GitHub Actions. I have added them as secrets before the stream, so that should work. And then, so the only thing that we need to add here, pull new EEPROM, oh yeah, this needs to be EEPROM. Pull new EEPROM files if present. Or maybe update EEPROM reference if newer EEPROM is available. That is a little bit more descriptive. Okay, this should be pull EEPROM, okay. GitHub Actions CI, update EEPROM ref. Okay, cool. Let's add this, and just gonna say add GitHub Actions cron workflow. I understand that this is not yet configured as like a cron on GitHub Actions, but you're gonna, oh wait, I didn't configure this repository either. Mix.git config, oh yeah, this should be updated. Okay. Okay. Push again. Whoa, what happened? Raspberry Pi EEPROM, what? What did we do wrong here? That's odd. Okay, let's see. Oh, I'm working in the wrong repository. Why didn't nobody tell me? It is great that this failed. Thank you, Git. Okay, so we wanted to go into the EEPROM repository, where this is actually already set up. Okay, so now we need to just make this undone. So the way we can do this, and actually, I'm gonna abort this. I'm gonna actually properly walk you through it. Okay, so we messed this up. So let's figure out how to unstuck this. Assume you're not using my git-get because I would default to GitHub with SSH. True, I am not. As I said, I will need to switch to a more comfortable setup over time. This is just what works for now on the stream. So let's actually copy the .github into the correct one in here. Recursive copy. Just quickly triple check that we got this file now. Okay. And in here is where we want to fix up our stuff. So now, what Maggot shows us in here now, actually also let me remove my camera so you can fully see this. So what Maggot shows us in here is we have an unmerged commit. But as we just figured out, we don't actually want to merge this commit into master because we did it in the wrong repository. So what I'm going to do is I'm going to press R, which brings up the rebase menu here. So Maggot is entirely menu driven. You might not have seen this because I just know the key bindings by heart, so the menu doesn't have a chance to properly pop up most of the time, but it is nicely self-documenting. So for example, if I wanted to say -I for interactive, you can see that the option actually gets highlighted if I enable it, etc. So this is like a nice little menu system. What I want to do is I actually indeed want to rebase interactively. I'm going to press I. And now it says pick this commit, add GitHub Actions cron workflow. And it tells us which commands we have. It tells us that Control-C, tells Git to make it happen. Control-C, Control-K is abort, which is very common. Emacs key bindings, you can find them anywhere. Then we have K for drop the commit at point. This is what we're going to do. Strikes it through. We're going to say Control-C, Control-C to tell Git to make it happen. And what's it complaining about? Nothing to do. Oh, I think this is what we wanted. Don't pick this, make it happen. Yeah. We needed to start the interactive rebase at the commit prior to the one that we had, because I think if you start an interactive rebase in Git on just one commit, you can only ever modify that commit but not drop it. Maybe I'm wrong, but this is how I interpret what just happened here. Okay, so now Let's see, which file is this? This is the firmware.github. I'm not sure if this still exists on disk now. No. So the .github has vanished with our commit as we had expected. So there's no changed files here. So let's close all of these old buffers. And then we have the cron. Yeah, no, that is obsolete as well. And where we want to go is in here. .github workflow cron. Okay, cool. So this is now the right place. Add GitHub actions. Cron setup. Okay. All right, push this. Cool. So at this point on GitHub, we should be able to see like the little CI dot next to our commit once it actually starts up. We can also check the actions tab here. Workflows are not being run. Oh yeah, we should probably enable actions. That is a good point. Didn't remember that you need to do that. I don't know if that actually works now or if I would need to force push again for it to pick it up. We're just gonna give it like a second here, but I don't think it's picking it up. Oh, wait. Didn't properly enable them? Did I not commit this correctly? .github workflows cron.yaml. Should that not be enough? This is weird. Let me check in the settings. Actions. Enable local and third party. Yeah, that's correct. What happens if I say new workflow? .github/workflows/go.yaml. .github/workflows cron.yaml. I mean, that should work, no? Should it at least not tell me if something's wrong? Okay, let's see what happens. Yeah, whenever I open this tab, it says they're not being run. That's really strange. Okay, so let's try, whoops, no, that's not what I meant. Yes, we're gonna amend this. Just gonna change the case here. Push force upstream. Okay, let's see if that helps. But it does not look like it. I wonder if there's like any naming restrictions, like if cron.yaml is some sort of reserved name for some reason. In any case, we're just going to use the UI then. Just going to say new workflow, blah, blah, set this up, sure, go.yaml, okay, start commit, commit directly to the master branch, create GitHub, actions, go.yaml, okay. Good. Now, well, this looks better, oddly enough. So we're gonna fetch from upstream. Okay. So why don't we just use cron.yaml, overwrite the go.yaml, delete the cron.yaml, overwrite go.yaml with cron.yaml. Just to exclude that as a source for mistakes and errors here. Okay. So let's see if something happens. Just in case, did you validate YAML syntax? Any email in inbox? Oh yeah, I should check my inbox maybe. Did not actually, oh yeah, you might be right. You might be right. That might be it. There should be GitHub YAML validate. Oh my God, really? Yeah, okay. Sure, I read all of this. YAML schema validator. No, wait, this is not what I meant. YAML validator. Any will do, I suppose. I'm not sure how many flavors of YAML there are. Okay, let's copy it. Valid YAML. So yeah. Oh, but that is odd, right? Why did that happen? Yeah, so much for the YAML validator. The best YAML validator. Oh, this one better be good. Valid YAML. And it didn't screw up my output. So yeah, don't know. Let's see, has anything happened in here? No. Actions are not being run. This is really strange. Also that like the go.yaml that we added didn't do anything. Like even the one that we added with the UI. So what else can we try? The branch is master, this is master. Name is CI, the actions look reasonable to me. I am actually gonna check in my inbox real quick. Nope. No error messages from GitHub. Okay, any suggestions? Maybe the output of the YAML validator was messed up because there is indeed a mistake in your YAML. Yeah, maybe the nesting's wrong or something. Yeah, that is a good theory. Let's check for some typical problems. Like, maybe there's a tab in here? No, these are all spaces. These are all spaces too. And so are these. So the thing is that, like, up until here, that is all just copied from a working file. And then I just added these two. And like they look okay. There's not that much that can go wrong here, right? And also, yeah, so there was also considered that in the other commit here, the one that we created via the UI, it also didn't run anything, right? So I'm kind of wondering, did you enable actions and settings actions? Settings, actions. Enable local and third-party actions. I think that means yes. Also the UI actually, yeah, see, it always tells me enable actions and then it doesn't show me the work. Why does it not show me the workflow, right? And then I say new workflow, I'm gonna say set this up. So what would this actually now do if I did start commit? Because we already have that file, right? Yeah, it's already named go.yaml. I suppose it would just reset it, right? Oh, one thing that we can actually do is we can just copy and paste this in here. See what happens. Preview. Paste your version into web editor. Yeah, just did that. This looks good, I want to say, right? Yeah. So one thing we can do though is we can just like really go back to this, right? I'm just gonna say start commit, commit directly, go.yaml, UI setup, try number 2. File with the same name already exists. Yeah, that is, that's the example YAML work. Let's try this. I thought I had already added it like that, but let's do it again together. So I added just, the Go vanilla now. That is like the example. So if I go to actions, I still see this page. It almost seems like a bug in GitHub. Like maybe this is because my repository is recently created. Like we did it on stream, but it was also a while ago. So I don't know. Can you also delete the other file? Sure. Oh yeah, I think we always had 2 files lying around. Maybe that is actually related. Let me do this. Let's fetch first. Okay. Delete mine. Delete mine. Push. Pushed. Have you tried turning it off and on again in the settings? Oh yeah, that's a good point. Let's see first though. Workflows aren't being run. Actions. Disable. Yeah. I think it did that now. Oh yeah, the tab vanished. So now, actions, enable. Tab's there. All workflows. No results match your search. But what happens if, oh yeah, no, same symptom. Huh. Yeah, that's really quite a roadblock now. I don't really know how I can continue here like that. Is there like, there are quite a few people reporting similar issues right now. Oh, unable to enable access for this repository. Yeah, that sounds very related. Yeah, I'm a little bit conflicted right now if I want to change to, oh actually, I just realized I had the camera off. Yeah, I don't know if I want to continue on GitHub Actions or switch to Travis for the purpose of this stream, but also it's been going for a while, so maybe we'll just try to do something else. Did you like read this issue? Is there any hope for a quick resolution, or are we just gonna have to live with that for now? GitHubStatus.com, it's degraded. You're working on remediation. This was 1801 UTC, so that was like 35 minutes ago. API requests, webhooks, actions. Oh yeah. They look very degraded. Okay. Yeah. Yeah, thanks for the hint. So I guess nothing we can do about this for now then. What can we do? Can we do something else? Everything for the, let's close all the unrelated stuff. This is also unrelated, in fact. So is this. Okay, let's see here. Yeah, this whole thing needs GitHub Actions. We could do the clean up old files code branch for completeness sake. All of the automation around pull requests, etc., also needs the GitHub Actions. If we go back to our to-do list, we should also update the issue template as trivial and update the website, but both of these can only be done once we have the EEPROM updates done. So that doesn't make much sense. Cool. So yeah, I guess I'm gonna take this as a natural stopping point then. If you have any more questions or want to see something specific, please let me know in the chat, and then we can do that. Otherwise, I think I'm gonna prepare to wind this down and call it a day for today. Let's see, this can go, this can go, this can also go. Secrets can go. Yeah, I had like the reference documentation open for all of the workflow stuff because it turns out there are secret name requirements. So for example, they must not start with the GitHub underscore prefix. And I had like the environment variable I'm using is called GitHub underscore user, for example. So yeah, I needed to rename these secrets. Gonna leave this open. gokrazy update demo, yeah, for sure. We can totally do this. So this is the Raspberry Pi that we're running. So what we can just do here is actually just go back to the compile command that we had in yesterday's stream. Updating the application is really cool, AB, yeah, that is correct. We can actually illustrate this even, I think. So actually, let me move the camera out of the way. Yeah, so right now it's booted from root. Partition UUID is this, and then partition is 2. So currently it's using the second partition. So if you go back here, run the update, it does the update, it writes data. This is taking a little bit of time. The Ethernet port on the Raspberry Pi 4 is much faster, but for some reason writing to the SD card is still pretty slow. haven't figured out yet why. It might be that we just need to use like a different driver or different settings with the driver, or that some optimization is not yet upstreamed. These are like the most likely causes why this is still slow. I think it should go much faster. But also I don't mind too much because it's not that slow. Okay, what does the update actually write? Yeah, let me pull this up. Okay, so before you wonder, this password here is only used for the Raspberry Pi development board that I'm using here, so it's completely safe to stream, don't worry. Then the first image that it's writing is actually the boot file system, and then the second one is the root file system that it creates here. And then the last one, you can probably guess it from the size, it's 446 bytes, is the master boot record. The master boot record, of course, doesn't really play a role, like in the sense that it doesn't contain a bootloader that the Raspberry Pi would actually use, but we just write it everywhere, like on all of the supported platforms, and the ones that are PC-based actually use it. So yeah, it writes these 3 images, so yeah, let's actually, okay, so this is still on 2, interestingly enough. Not 100% sure why. I would have expected it to go to 3, I think. But nevertheless, can figure this out later. What we can actually take a look at is the web interface. And you can see here that the timestamp 2131. No, wait, this is 522. Oh yeah, so wait, this didn't actually update. So what did this do? Interesting. Why did it restart into the old thing? Well, one thing we can do is just try it again, see what works. This is interesting because this worked yesterday, because I did it on stream for adding the serial busybox here. So it must have broken in the meantime, which is unexpected. Oh yeah, this actually does look better. Yeah, 4206, yeah, that's us. Okay, command line. Yeah, now it's using the O3, so that's the B partitioning and the AB partitioning. Yeah, I don't know what went wrong the first time. Should definitely look into that. We'll figure it out eventually. In practice, it does work reliably though, because I do have monitoring for the last update timestamp on all of the devices. I didn't get any alerts, so yeah, must be constrained to some fact of our environment. Okay, yeah, this is the web interface. You've seen this before if you've been on stream early enough. If you haven't been, yeah, we can see all of the processes here that do things such as obtaining an IP address like via DHCP, synchronizing the clock via NTP as soon as it's actually available. The Hello World program, which just prints Hello World in a loop, the serial busybox, and the break glass. That is all that we have right here. Cool. So let's give this one more shot. Let's see what happens here. Oh, now it says actions enabled. I think that pop-up didn't come before, but it still says enable actions on this repository. So maybe it's still just degraded enough, but why don't we? Oh yeah, so this is neat. So the mode that I'm using here for changing my window configurations like that is called Winner. It is included in Emacs by default, I think, and it has like Control-C left and Control-C right, which just undoes or redoes the most recent change to my window configuration. So if I full screen the compilation window and I want to go back to the arrangement I had before, I can just undo my window changes, which is pretty cool. So what we're going to do here now is commit, amend, delete my config, force push, and see if that triggers a new action run, if they're like working again. Looks like a no. Okay, so we're gonna leave that be. When does the kernel get updated? What do you need to do to update dependencies for a gokrazy app? Yeah, great question. So there is a kernel repository, which is very similar to the firmware repository that you've seen on the stream, and also very similar to the EEPROM repository that we have just set up. The kernel repository, as you would maybe expect, contains the Linux kernel, the VM Linux image, and the device tree files that you need to boot the Raspberry Pi. The kernel repository is pulled like any other package. So if we go back here, yeah, this is not explicitly listed here because it happens in the background, but if we go to gokrazy/hello, I believe, we check out the go.mod. Notice your kernel builds come very quick after the vanilla release. That is correct, and I'm going to tell you why in just a second. So we can see the gokrazy kernel repository being mentioned here. We can see this is 2020-0520. This is where it pulls it in. So if we wanted, so the image that we're building here will remain the same as long as this go.mod file remains the same, right? That is sort of the idea behind Go modules, that your builds are reproducible. So if I wanted to really update this, what I would need to do is, let's go like the full way and ignore the proxy for now, and like pull in a new kernel version. It doesn't pull in anything because there's no newer kernel version. But under the assumption that it did, you would now see a different version string here, and then the packer, which is the program that we use here to do the update, would actually pick up the new kernel version from the Go repository, from the Go package, and include it in the image. So that is like the client-side part. And the way I automate this is I have a cron job running on my computer every day in the morning that actually just goes through all of my gokrazy instances. Like I have a couple of directories like this. And then it just does the go get -u on all of the like common infrastructure. And depending on the specific thing that I'm working on, also on the actual applications or not, like depending on whether I want them to be auto-updated or not. What proxy do you use then? I do use the default proxy. I just am in the habit of turning it off whenever I do a go get, because then I might get the cached version, and I don't want the cached version whenever I do a go get. Okay, so that is like the client-side part of the updating, where you can pull in new versions as soon as they are in the gokrazy/kernel. Now, how does that repository get updated though? So here you can see that we also have a cron branch, and in the cron branch we also have a Travis file, and in the Travis file we also have this pull kernel command, which is what we were working on in the stream most recently. So the pull kernel, it runs every day. Okay, actually, let me see. travisci.org, I believe. Gokrazy kernel. See if we can look into this. Build history, cron, yeah. So this is the most recent build. You can see it goes and goes, and then it eventually says already at the latest commit. And the way this works is, it's very similar to the other one, but because this is for the kernel, there is some custom logic in here to parse the kernel.json file that describes the kernel releases. Okay, and then what this cron automation here will do is it will create a new pull request. And in a new pull request, like this one here, it starts out with a file change. And the file change is this one here, right? So this should look a little bit familiar to you because we had just written the tool to update it for the EEPROM. And in the EEPROM, we have like the git revision of the EEPROM repository. In the kernel, we just have the URL to the kernel tarball. And it does the pull request, and the pull request triggers this whole Travis automation where a Travis job, if we look at the build history, we can probably see this in action. Or maybe we need to look at branches. Oh no, pull requests, I believe. Yeah. So you can see there's two runs here. The first one, yeah, it does a whole lot. Sets up like a Docker build environment, barks, and then it configures the kernel and compiles it on Travis. So this takes a little bit of time. You can see it took 25 minutes to build the Linux kernel for gokrazy on Travis. Then once this is done, it actually updates the pull request and it adds the VM Linux file, like anything that has changed. And then that triggers another Travis run, which is this one here. And that actually writes to, yeah, this is a throwaway password too. This actually writes to the bootery, which then does like the continuous integration and like updates the actual Raspberry Pis with that image and checks if the new kernel actually works. And if it does work, it says, okay, this has worked. I'm going to automatically merge this pull request. So you can see all of this in action because it has labels that indicate what it's doing. So you can see the pull request came in, Travis run passed. So this means the compile passed. It added the please boot label, force pushed its pull request with the new VM Linux file. And then I triggered another Travis run. And then that added the please merge label and actually merged it. And then that is like the full history of this. So that is why as soon as a new kernel version is released, at most 24 hours after that release, the cron job will have run, it will have sent a pull request will have triggered the build will have succeeded on the CI, ideally, triggered a merge, and that's why we have entirely automated updates in gokrazy without any human in the loop, unless something goes wrong. Okay, never noticed the default proxy being out of date. Wonder how much it caches the latest version. Yeah, so it is usually not out of date. It is only out of date in the situation where you have just pushed now, and your repository is already used by some other people, because then it hits the cache, right? And it doesn't yet know that there is a new version. So you might need to force this. You might need to force this either by specifying the version, but that is cumbersome, or by going around the proxy, and then you pull in the new version, and then you can do another go-get with the proxy, and then that pulls in the new version because the proxy notices, oh yeah, the specific version that the person is asking for is not yet in the cache. But yeah, this is like a little stumbling block if you're working on repositories that are actually in use, be it automated or not. So what else? Doesn't the repository get big with the VM Linux? You are correct, but that is a problem for later me. No, so there's a lot of kernel versions in here because we have been doing this for a while, for a couple of years at this point. Yeah, this will accumulate. The repository will get bigger and bigger over time. At some point, I think we're going to do like a split of this where we just throw away the old history because the history is not actually so interesting. There are a couple of interesting bits and pieces, and you can kind of distinguish between the commits that start with auto update, those are not interesting, and the ones where something's actually being changed, right? Like the device tree is being changed because we dropped a patch here, or the command line is changed because we enabled some other option, or any of the new patch comes in here or something like that. Yeah, so yeah, I think at some point we're just going to do like an archival of this repository and just put a new one in its place. We're going to see how well that goes. Yeah. Okay, how big is that repository? Let me check. I don't think I have it here. So let me just fetch it. Okay, I assume you have a hardware farm for your build targets. Kinda. So I'm actually building on Travis. And then what I have is hardware, which is in here. This is a process called the bootery, which is part of the whole repository thing here I call bakery. Where the already baked image will be delivered by Travis to this program, which then distributes it to my Raspberry Pi 3B, 3B Plus, 4B, and the PC Engine's APU. All of those are like in a little, yeah, they're actually on an IKEA pegboard, which is nice to work with, because you can rearrange all of the components and just use like zip ties or something like that for strapping them on and then reconfiguring them. But yeah, they get the image and then they install it there, and they're connected via a serial port. You can see here, there's a bunch of serial identifiers for like either a specific USB to serial adapter or a specific one of the same kind. So we can't distinguish it by product and vendor. So we need to actually look at the serial number. So I have like 4 USB to serials hooked up to this Raspberry Pi, and they're all connected to the other Raspberry Pis. They're going to be updated over the network. And then if they're going to report back success via the serial port, the update is a success. And then it will go on with all of the Travis and GitHub pull request machinery. Okay. .git 800 megabytes. Yeah. Let's see what a GC does, if that's going to get any smaller. No. Okay. So yeah, 800 megabytes it is right now. Undoubtedly, it is large, but yeah. We should find a better way for this as well. Also, actually, so we started this project before Go modules were a thing. And it turns out that Go modules for actually just building your images, like the part that I'm doing in here, where I have the go.mod file here, is actually very beneficial, because previously, while we were using the Go tool still in non-module mode, it would actually need to check out that Git repository. So it would need to actually clone these 800 megabytes, just so that it could then throw away all of the history and just use the latest version. In here, it only actually downloads the Go package, which is a zip file. So this is much better, because now we get the file, which is only like, I don't know, 20 megabytes? Let me see. gokrazy kernel, VM Linux, doesn't actually say in here. Oh, 33 megabytes, fair enough. So we only download that. But for sure, the backend Git repository is still large. And yeah, I don't know at which point GitHub will get mad at us for this repository being so large. So Bradford stores his testing QEMU kernel as a blob in Git, not in the repository. Yeah, interesting. I don't know exactly what changes we would need to make for this, but it might be something to look into when the repository becomes too big. Or you could use a pristine branch with flattened history. I guess. But then I would need to look into how the branches work with the versioning. So currently we just use no tags on this at all. And yeah, I don't know, like, do branches automatically map into Go module import paths? I think only if they follow like the semver version. And then, like, I don't know at which point we would branch. So yeah, this requires further thought. Check this out. Yeah, I'm going to check out the link later. Cool. Were there any other questions I missed? Oh yeah, does this mean there are no signed releases? In a way. Yeah, it depends on which part of the ecosystem you look at, right? So the there's the go.sum file, right? So if you wanted to verify that the kernel that you're getting with gokrazy is the kernel that you're expecting to get, so if you want to verify like the entirety of the proxy and the GitHub repository backing it, etc., you would just need to put a checksum into your go.sum file. Now, how would you obtain this checksum? I don't know. The thing is, there's a lot of points of trust in this chain, right? So first of all, you need to trust the kernel.org to deliver something that is actually the Linux kernel, right? Then you need to trust it to deliver this also to Travis, where we actually run, right? Maybe the Travis environment was backdoored and is untrustworthy. Then we're going to interact with GitHub. So GitHub should accept the commits that we're doing on Travis. But if we're going to sign them on Travis, then where does the chain of trust start? If it starts on Travis, is it really that valuable? And if you're saying Travis and GitHub are trusted, then you can probably just like use the Go tool to update these as we're currently doing. And the Go ecosystem in terms of like the sum database will verify that at least there's no man in the middle going on in the path. And as long as GitHub can be trusted and Travis can be trusted, and in the future, once we merge Travis and GitHub, then it's only going to be GitHub that needs to be trusted. Assuming that is the case, then everything should be kind of okay. Reproducible builds helps a lot. So you can reproduce the binary you get from Travis, something for another stream. Yeah, so check this out. So in here, we have gokrazy build kernel and gokrazy rebuild kernel. So what I'm going to do is, I don't know if I'm in the Docker group. We'll see. I'm going to install these. I'm going to run rehash gokrazy rebuild kernel. Going to run this. Yeah, not in the Docker group. Let's see. Docker stream. Okay, new group Docker. Gokrazy rebuild kernel. Cool. Okay. Yeah, so it turns out it is actually really easy to build your own kernel in gokrazy. There is this command that you need to run. It's called gokrazy rebuild kernel and is running right now. So this does everything. This is the same thing that runs in Travis. So if you want to verify that the images that you're getting are bit for bit equal, you can just run this after you checked out the Git repository. And if Git reports any changes, then something went wrong. And if it doesn't, then everything is bit for bit equal. And yes, indeed, reproducible builds helps a lot. Our kernel that we build is actually reproducible, which is why we can pull off this trick. So if you decide that you don't want to trust like Travis and GitHub, etc., you could always, like, if you want to be hardline like that, you could always just have the gokrazy kernel repository checked out locally. Use a replace directive in your go.mod file, like we have in here. You would just replace the kernel directory with your local build. You would then you could run your entirely own updating chain, right? You could say, oh yeah, I'm just going to want to pull from kernel.org, see if a new version is there. automatically, update to the new ref, build a new ref locally, and none of this ever leaves your disk or has to do with any other provider other than kernel.org, which you may or may not trust based on TLS certificates, or you could trust it with, I don't know if they do GPG releases, maybe. You could build anything around this and then just locally build your kernels and use it like that. So the level of trust that you place into the automation is entirely on you. Supply chain security is a nice Pandora's box, for sure. Yeah, as you can see by me talking a lot about it right now. How do I win the fight against the fear of learning something if it looks really intimidating? Thanks so much for reading my question. Yeah, sure. The fear of learning, well, if it looks intimidating, you need to break it down, right? You need to start small. Fix a little thing here, go on, and yeah, I think the trick is to not get discouraged. So you really need to want this. In this case, I really wanted to build infrastructure that would work for me over the course of many years. So I have started this, I think, in 2017. So this is the third year of me doing it like this. And it has actually worked out. So previously I had not updated many of my Raspberry Pis that I had at home. And now it actually works because it's automated and I don't need to touch it. And it breaks rarely. And when it breaks, it's easy to fix. So if you have the right motivations, I think you can like step for step just approach it. I realize that's sort of a non-answer, but if you have any more specific questions, I'm happy to help. Could build on GitHub Actions and Travis and cross-report if mismatch. For sure, yeah, you could. You could also, like, there is the trend in the TLS community to do sort of the transparency log approach to issuing TLS certificates, where you have these distributed places where you verify that everything is in order by reproducing these logs that they spit out cryptographically. You could do the same approach here, right? Yeah, you could build in two places and verify. You could occasionally just build locally and verify. You could always build locally and verify if you don't trust it. In practice, I like the auto updates so much that I just have it set up like this. Nice, you can't reproduce the Arch Linux kernel because they use, the key used to sign modules is unique per build. That makes sense. I don't use any of the secure boot stuff or module signing or anything like that here. So I don't face this issue. Unique per build, that sounds like trouble actually though, because don't you need to store this key in like your hardware security module for your computer to be able to boot up? Or maybe I'm misunderstanding which key you mean here. I think there's more than one key in the Linux kernel actually. Yeah, so the kernel build is taking a little time. I had remembered it faster, but yeah, we're gonna see how long it took when it's actually finishing. Might be that it's growing over time, or maybe because we added a couple of new options. But I think, yeah, it shouldn't take much longer. More than one key, yes. I'm a bit unsure about the details, frankly. Sphinx is also a problem for kernel docs. Oh, Sphinx is like the documentation generation thing? Yes. Yeah, haven't used Sphinx personally. I just don't have a need to build the docs, but obviously in Arch Linux and other distributions, it is good style to build the docs. Okay, so the build's almost done. We're gonna wait it out, see how long it took. I'm going to see if there's any differences here. I'm going to see if Travis is trustworthy or not. Oh, come on. All right. Okay, yeah, so git status, no diffs. So the kernel that we just now built, you can see it on the timestamp 2103, and also the device tree files. It is bit for bit equal with what we have in Travis, or in the Git repository built by Travis. Nice, yeah. Okay. Are there any other questions or requests for demos or anything? I think Stapleberg would appreciate Brad's 6-minute lightning talk on Embiggen Disk if you missed it. Really dense, packed with init QML links. I remember this. I remember his talk. I remember Embiggen Disk too. Let me pull this up because it's really cool. Yeah, the talk was great because he had like a slide deck of 70 slides or so, and he just went through it and it was like action-packed. Loved the talk. Embiggen Disk is also a really cool tool here because what it does is you can run it in like a container that you have, and will enlarge or embiggen your partitions, logical volumes, physical volumes, file systems, crypto thing, anything that you have that is nested like that. And then, just resizes it automatically. And it's great. I'm actually using this in the distri update procedure. If we check the release notes, yeah, this is not great on such a small screen. Need to fix this. Yeah, using it here. So the old disk image that we had was 7 gigabytes in size, and 7 gigabytes is not sufficient to hold 2 versions of distri at the same time, temporarily for the upgrade. So I'm truncating the image to give it 7 more gigabytes. And then in distri, I'm installing embiggen disk and I'm running it on Slash. And then like all of the other layers are automatically resized. And that's how the disk image is now grown, both inside and outside. It's pretty cool. Excited for a stream tomorrow? Yeah, it's gonna be fun. What pizza are you making tonight? No pizza tonight. Can't eat pizza every day. It turns out that makes you fat. Look forward to tomorrow. Nice. That's where I shared the git fetch for VM Linux. Oh, nice. Yeah. Cool. I'm gonna look to the line 444. Let me pull this up. I don't have copy and paste from the Twitch stream to here, so this is gonna be quicker. Master integration test.go. Oh yeah. Let's see, 444. Oh yeah. Oh, I see. Yeah. It just fetches it out. So then and then I suppose the kernel is just always like force pushed, like replaced without any trace to it, and then it can be garbage collected. I assume that's the trick. Do you also run distri repo on a gokrazy device? Can you clarify the question? Like, do you mean like, am I hosting a distri repository? Because you can't quite run a repository, but you can totally install packages from a repository. And you can have an installation. Hosting, yes. No, the hosting is actually not happening on a Raspberry Pi because at the time I started distri, the Raspberry Pi was not actually able to saturate a gigabit network interface. That only came later with the Raspberry Pi 4, for which we're adding support right now. So I have the distri repository on a separate computer, an older computer of mine, that I'm also using for the Debian continuous integration builds. Still, actually, because nobody took that over, so I need to find a successor for that at some point. For the Go packaging in Debian, so it does like a full Go path that resembles the Debian repository, and then does like tests to see if changes break anything. And on that server, I'm also hosting the distri repository, and that can actually saturate a gigabit no problem. Cool, yeah. Yeah, I'm gonna leave that open as a to-do, like the evaluating. Storing the kernel as the VM Linux image as just a ref without the history to keep the repository size down. Why don't we do one more check of the GitHub status to see no new updates, action still degraded. Okay, so we're gonna call it for today, and then I'm gonna see you all tomorrow, same time in the stream that I'm doing with Matt Layer together. I have no idea how that's going to work in Twitch, but we're just going to both start streaming and figure it out. We have the rest already figured out. So that's going to be a lot of fun. Cool. Yeah. If you want to get in touch, find me on Twitter. And thanks for hanging out. And that's going to be it. Thanks. See you around.